Hello guys, welcome to today's lesson. Today we are going to consider the topic redox titration. Redox titration. And let's look at a typical sample question on this topic. A is a solution of potassium tetraoxomanganate 7 containing 1.6 gram per dm cube. And B is a solution of iron 2 tetraoxosulfate 6 of unknown concentration. Question 1A says put A into the burette. Pipette 20.00 cm cube or 25.00 cm cube portion of B into the conical flask and add 10 cm cube of dilute H2SO4. Titrate A against B in the conical flask. To repeat the titration 2 or 3 times to obtain consistent titers. Tabulate your result and calculate the average volume of A used. The equation for the reaction involved, the titration is as follows. MnO4 plus 5Fe2 plus 8H plus gives Mn2 plus 5Fe3 plus 4H2O. B says from your result and the information provided, calculate the concentration of A in mole per dm cube as Bi. II says concentration of B in mole per dm cube. III, concentration of B in gram per dm cube. IV, number of moles of A in the average titer. And V, mass of Fe2 plus in the volume of pipette used. And you are given the relative atomic mass of iron, potassium, manganese, sulfur, and oxygen as shown. Now let's look at the typical titration result based on this sample question. We have the volume of pipette used was 25 cubic centimeter. We have rough titer, first titer, second titer, and third titer. The rough titer was 26.5, first titer 27.2, second titer 27.2, and third titer 27.2. Alright, so for us to find the average titer, we have to add the first, second, and third titers together and divide the answer by 3. Okay, so since the 3 titer values are consistent, we simply add them, divide by 3, and the answer is 27.20 cm cube. All right. B aspect says we should find, that's BI says we should find the concentration of A in mole per dm cube. Now, solution. The mass concentration of A was given as 1.6 gram per dm cube. The molar mass of A, that's potassium permanganate, when you calculate, you get 158 gram per mole. Of course, you have to show calculation. Now, using the formula that says molar concentration equals to mass concentration divided by molar mass. So we divide the mass concentration, which is 1.6 gram per dm cube, by the molar mass, which is 158 gram per mole, and we get 0.0101 mole per dm cube. Of course, you must write your answer to 3 significant figures. So as you can see there, that answer is written to 3 significant figures. BII says concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Now we have COA. Of course, this is redox titration. COA means the concentration of the oxidizing agent. The oxidizing agent is the potassium permanganate, and the concentration of that is what we just calculated as 0.0101 mole per dm cube. So COA is equal to 0.0101 mole per dm cube. VOA is the average titer. The CRA, that's the concentration of the reducing agent, that's the iron 2 in the conical flask. And VRA, that's the volume of the pipette we used, which is 25 cm cube. NOA is the number of moles of the oxidizing agent in the balance equation, and NRA is the number of moles of the reducing agent in the balance equation. So we have the formula that says CAVA over CBVB equals to NA over NB. But since this is a redox titration, we simply swap those terms in the expression. So we write COA times VOA divided by CRA times VRA equals to NOA over NRA. And after that, we have to substitute the value for NOA and NRA in the balance equation in the next step. So in the next step, we copy the expression and equate it to the number of moles of the oxidizing agents to that of the reducing agent. So CRA will give us COA times VOA times 5 divided by VRA times 1. And we now substitute those values and we get 0.0549 mole per dm cube. That is the concentration of the reducing agent in mole per dm cube. III says we should find the concentration of B in gram per dm cube. That's concentration of the reducing agent in gram per dm cube. And we have the formula that says molar concentration equals to mass concentration over molar mass. So we simply find the molar mass of the reducing agent, that's the B. We find the molar mass of the B, add the atomic masses, and that gives us 152 gram per mole. Now we substitute. We have mass concentration, that is the same thing as concentration in gram per dm cube. So mass concentration equals to molar concentration times molar mass. So we substitute the molar concentration and the molar mass there, and we get 8.34 gram per dm cube. IV says we should find the number of moles of A in the average titer. Number of moles of A in the average titer. Now note that A is the oxidizing agent. That's the potassium tetraoxomanganate 7. Now there's a formula that says N equals to CV over 1000. N equals to CV over 1000. So we substitute our CV now is the COA, that's the concentration of the oxidizing agent, which is 0.0101 mole per dm cube. Our volume is the average titer, which is 27.2 cm cube. So when we substitute, we get 0.000275 moles. And this is to 3 significant figures. The last part says we should find the mass of iron 2 in the volume of pipette used. Now, volume of pipette used was 25 cm cube. So we need to find the number of moles of iron 2 in 25 cm cube by using the formula C. N equals to CRA times 25 all over 1000. CRA is the molar concentration of the reducing agent, which is 0.0549 times 25 divided by 1000. And the final answer, the result is 0.00137 mole. So we now use another formula that says mole equals to mass over molar mass. Mole equals to mass over, make molar mass subject of formula. So mass will be equal to mole times molar mass. Mole equals to mass over molar mass. Mass equals to mole times molar mass. So when we substitute, we have our mole as 0.00137. The molar mass as 56. We multiply that, we get 0.0767 gram of iron 2. Thank you for being a part of this lesson. Do have a wonderful day. Bye.